Hey guys, we're welcome to Chapter 8, talking about momentum. And so the first couple sections we'll look at is momentum and impulse, which is the thing that changes momentum. So here we go. So the concept of inertia, we introduced that as basically an object at rest or an object in motion based on its mass. The more mass it has, the more inertia it has. Well, here we're looking at the concept of inertia in motion or momentum. And I know we've all heard that term before, but we're going to put a little more science to it, of course. A moving object can have a large momentum if it has large mass, high speed, or both. So we know it's harder to stop a large truck than a small car if they're moving at the same speed. And we know that the truck has more momentum than the car, and we know that momentum, we mean inertia in motion. So when we say that, remember inertia was mostly based on the mass of the object. So momentum is basically mass times velocity. The equation we use is P equals mv, mass times velocity. When direction's not in a super important factor, we just use mass times speed, which gives us the same units as a kilogram meter per second. So a moving truck has more momentum than a car moving at the same speed simply because it has more mass. The fast car can have more momentum than a slow truck. A truck at rest has no momentum of all. Mass times velocity, if the velocity is zero, that means the quantity of mass times velocity would also be zero, so zero momentum. So can you think where a roller skate and a truck would have the same momentum? And there's a lot of text here, but basically if we can get them to multiply to the same thing, we can get that to happen. So a 1,000-kilogram truck going at 0.01 meters per second versus a 1-kilogram skate going at 10 meters per second, they would give the same momentum value there. So just to rehash real quick, the main factors that affect an object's momentum are mass and velocity. So once again, P equals mv, mass times velocity. So there's momentum in a nutshell. Let's take a look at what impulse is, and an impulse is what affects momentum. So an impulse is a force sustained over a period of time. And so if you apply a force for a longer period of time, there is a more of a chance of a change in momentum than if you apply it for a very brief amount of time. Both force and time are important factors in changing an object's momentum, which gives us the equation for the impulse. So impulse is force times time, the product of force and time. F is the applied force, and T is the time in seconds that the force is applied for. So the greater the impulse exerted on something, the greater will be the change in momentum. And so we have, once again, the equation Ft equals delta mv, or delta p. So more on that of the notes when we come into class. But the impulse is the change in momentum, or Ft is the change in momentum. So in order to increase momentum, you have to apply the greatest amount of force for as long as possible. So a really good example of that is a golfer teeing off, or a baseball player trying to hit a home run, right? The guy's got to hit it pretty hard and has to make good contact with it and follow through with their swing. So you don't just stop the bat or stop the club as you hit the ball. You follow through. You're trying to maximize the amount of time the force is being applied. So decreasing momentum, well, imagine you're out of control car and you have a choice between hitting a haystack or a concrete wall. You should choose the haystack. The reason for that is this: if the change in momentum occurs over a long period of time, the force of impact is small. So we have this little diagram here showing the car that has a big velocity, and if I apply a big time, a small force is applied to the car. which means you don't get damaged, right? But if the impact or the change in momentum occurs over a very short period of time, the force of impact is large, and here is this diagram right here. Once again, big V, car driving fast. If it takes a small amount of time to stop the car, that means the force applied to the car would be really big. Hence, a car collision that is yields a lot of damage. So not the greatest situations. So when you hit either, you're still going to come to a stop. Whether you're hitting the haystack or you're hitting the wall, you both come to a stop, and the momentum is decreased by the same impulse. But what that doesn't mean is the amount of time or the amount of force. Once again, if the force is big, the time is small. If the time is big, the force is small. And so we have to know that it's the product of force and time that's causing the impulse to change the momentum. So to keep the force small, we extend the time. And so there's lots of reasons and lots of examples that we can think of that to keep people safe in cars. And once again, when we come into class, we'll discuss this in a little more detail. All right, that's it. Thanks for watching. Talk to you guys later. Bye.